Hello everyone and welcome again. So this is another tutorial. I will talk about the serial EEPROM, which is the ATmega ATmel AT24C 256C. Okay, again, it's a serial EEPROM, require only 2-wire I2C compatible, and it's got 768,000 of bytes. Okay, and we talked last time about this of how to do the writing function and also how to improve the writing cycles by developing the update function. Okay, and also we learn how to connect this chip to the MCU, which is the Arduino in this time. Okay, again, I connect all the addresses to 1 or to the VCC. Ground, I connect to the ground, SDA to SDA, SCL to the SCL of the Arduino Uno, write protection to the ground, VCC to the VCC. Okay, so today I will talk about very important topic. Okay, a lot of beginners, they will face this problem and they are not really fully aware about this issue, which is the address or the cell address wraparound, whereby we will see how the address, okay, will be wrap around, whereby we can store the data in the address more than this. Okay, well, actually it cannot, it's impossible, but we will see what's the issue with the address. Okay, so let's talk about this problem. Okay, before we talk about this, let's see some example. Okay, let's see some example. Sorry. Okay, so this is just example, is a very straightforward. First, we write the data to this address. This is the maximum address. Okay, because we say this is the full address of the memory. Okay, and since we start from 0, so this will be the maximum. Okay, in the maximum I store this, then I will read it again. First I will just read, store and read again, and in this time I just use write EEPROM. I'm not using update, and this is the function we already discussed about it in the previous tutorial. Okay, let's run this. Let's add something here. Progress. In progress. Okay. Okay. So let's upload this. Cancel. Okay, we will see now. It's very normal. We are updating this address and reading it back again. It's normal because this is the last address. Okay, it's reading now. Yes, 165. Okay, so since this is the last address, so it means we cannot go more than this. I mean, if I go for this address, I shouldn't able to access. So if I upload this, actually I shouldn't access this. Why? Because this is more than the maximum of the EEPROM. But surprisingly, we can see it works actually and still can read and write to this address. See? If I go even more, let's say 9. I change this to 66. Okay. and we can see its function. We still can access that address location. Here we go, 66. But wow, it's very surprising, isn't it? Because we can see the maximum is 32,768, but we can go up to 32,769. So where we are writing actually, does they lie to us? Do they lie to us when they do the data sheet or what? Okay, so we will learn today what is this trap is. Okay, what it's called, that is called address wraparound. Okay, so let's come here. Okay, let's assume now. Okay, sorry. Okay, we assume we have the memory of 4 locations. Okay, so memory with 4 locations, then it will be addressed will be double as 0, 1, 2, and 3, isn't it? This is in decimal. Now let's convert this to binary. Then address is in binary. In binary, how it will be? It will be 0B00, 0B 01, and 0B 11. 0B 10 and 0B 11. So this one will be 0, will be 1, 2, and 3. Okay, so these are the addresses. But be careful. If we come across the SPI, okay, if we come across the SPI, we can see that actually we access the memory locations. This is the memory location. We access it by using 2 bytes. Okay, so it means every writing through the SPI to the EEPROM, we use 1 byte. Okay, we use how many bytes? We use 1 byte. So now, since the SPI access use a byte wide, which is equal to 8 bits. Okay, so this one, if you want access to any SPI location, you need to write 8 bits of addresses. So 8 bits, if I want to convert this now to 8 bits, it will be so the SPI transmitting equal to 0p 1 2 3 4 5 6 7 8 1 bytes. This for 0. Now we have 0b 1 2 3 4 5 6 7 8. This for 1. 0b 1 2 3 4 5 6 7 8 and 0B 1 2 3 4 5 6 7 8. Okay, yes. So now this one will be 0. This is 1, 2, and 3. Okay, we can see now this is 0, 1, 2, and 3. This one where we send to the SPI. Okay, so now when we try to access more, let's say we access not 3, let's access more than 3 locations. Let's say we access location number 4. Okay, let's go for location number 4. For location number 4, we will go for 0B binary 1 2 3. Wait, let's copy this so we will not have headache with the zeros. Okay, so number 4 will be 1 0 0. Okay, 1 0 0. This is what will be sent by using the SPI for location number 4. But actually, the EEPROM decoder, address decoder, will take only the first 2 bits. Okay, because it works on 2 bits only. And these 2 bits actually is a 0 0. So the address will be wrapped over to number 0 back. So the 4, since yes, we are go out of the range of the memory locations. 4 is 5, but actually it will go back to 0. And so on if you go for 5. Okay, let's say now we want to go for 5. 5 actually is what? Is number 1. And so on. So this is what happened actually inside the memory. So now let's come again to our memory. If you see our memory, the maximum is this. Okay. This is the max location. 767. Okay. Which let's say from 0 to 767. Okay. Now let's bring the calculator. Okay, bring the calculator here, and let's see. Convert this from from decimal to binary. So decimal will be 32,767. Okay, here we go. You see, this is the binary. So here we have 30, 1 2 3, and here we have 1 2 3 4, 1 2 3 4, 1 2 3 4. Okay, so this is the locations in decimal and in binary. Okay, start from this to this. So now if we add more, if we go to, let's say, 32,768, let's see, with 68, these all become zeros, and we add another one here. Actually, this one, there's another 0 here because we send 2 bytes. Okay, again, when we sending address, we send 2 bytes. Okay, so now when we change 32,768 C will happen, surprise. Okay, it will go to this 0 change to 1, and this all 0. So when you come to this address, when we send to this address 678, actually we wrap over back to 0 location. Even though you still can access to this location, but actually this is not an extra locations for, it's not a bonus for you, but actually you wrap over or you wrap back to the to location number 0. And same if you go with 9. Let's go with 9 here. So actually we go back to which location? Yes, I guess you guessed it. I will go to location number 1. Okay, and so on. So actually it's very important to maintain the address at exactly the same that they give us in the data sheet. Even though sometimes you still can access more than this, but actually you wrap back to the 0 locations of the memory. Okay, so now let's do some testing. So let's access, we go back to 0, 0. Or before that, let's comment this and we check location number 0. And actually let's add more. 0 and number 1. Let's see the data that they store here. Okay, upload, thank you. Okay, writing in progress. Actually we are not writing anything now. Reading. Okay, so number 0 is 156 and location number 1 is 66. Okay, good, remember this. Now let's update 7, 8 and copy. We update 7, 9. So this one actually will this address will be warp bag, this one, and this will be warp bag to 0, and this one will be warp bag to 1. Okay, so this one should be 9, 8, 9. So let's store here 1, 1, 1, and this one 2, 2, 2, and let's check again. And remember, before that we have 156 and 66. Okay, done. Okay, now it's writing, reading. Here we go. You see now, for address number 0, this one, address number 1, this one. Okay, so here is very, very important to take care of the address wrapping or wraparound. Okay, if you go more than the address that mentioned in the data sheet, actually you are wrapping back to the 0. Okay, so be very careful of this. It's very big fat trap for young players. Take care of this, and I hope to see you soon in the next tutorial, and I wish you have learned something with this tutorial. Thank you very much. See you soon.